want to talk through this worksheet here, polynomials, roots, multiplicities, leading coefficients, and writing equations. I may not do this whole thing in the video, but I do have the answer key posted for you, but I do want to talk through a few essential parts. Okay, so first of all, anytime the equation bounces, you see how that it's hitting the x-axis and then bouncing off? That tells us that it's got what we call an even multiplicity. Okay, so let me back that up a tiny bit. If you think about, say I've got the equation y equals x minus 3. If that's my equation, then I'm going to go through, I know it's got a 0 of 3, 1, 2, 3, but it's going to be a line that passes through. It does something, pretend I can draw a straight line, it does something like that. So the fact that it has one 0, we could call it a 0, we could call it a root, we could call it an x-intercept of 3, doesn't necessarily give us enough information to tell us what it looks like. If we have this graph, y equals x minus 3 squared, it still has only one unique 0, but because of the square, it's not a line. It's a parabola, and you know, because of the transformations, this parabola shifted, and it's opening up something like this. And so this sort of behavior I would call a bounce. Okay, and a bounce will happen anytime we have the multiplicity is what power, or what power is the factor raised to, or we could think of it as, my brain just stopped. Well, how many times that 0 shows up in the equation. We could also see, if I could take y equals x minus 3 cubed, and you may remember that this, instead of passing through the origin, got shifted 1, 2, 3. And then this does something like that. I call it Disco Man because he's staying alive. Okay, so on this one, this sort of behavior it's a bend. Okay, and this had a multiplicity of 3. It showed up, we had 3, you could write this, 1, 2, I mean, I don't know why you would, but you could. 3 times. That one particular unique 0 showed up 3 times. It has an odd multiplicity greater than 1. Okay, so the way that when we start looking at these polynomials, if it's got a multiplicity of this just happened exactly 1 time, then I would describe this, I call this, it's saying it passes through. It passes through that 0, and if it's a curve, it'll do something, oh, well, there it is. Something like that. It's just passing through. There's no sort, if it has no sort of a bounce or bend. If it's got an even multiplicity, it bounces. So it could either bounce above, or it could bounce below, it could bounce and then keep doing other things. If it's got an odd multiplicity, bigger than 1, okay, so a multiplicity of 1 passes through. An odd multiplicity bigger than 1 has that bend, and that's how we're going to describe that. And then we also know that if it's got, we always want to look at our, so say I have a polynomial, I don't know, 2x to the 5th plus, I don't really care. Okay, something like this. When we see, and we're in standard form, and our degrees are going down. Okay, if this is our largest degree, if we've got this degree of 5, it's an odd degree. That doesn't make it an odd function. We talked about that earlier this year. There's a difference between an odd degree function and an odd function, like calling it actually an odd function. Since it has an odd degree, what we know is that our end behavior, it's going to do, who knows what it's going to do exactly? Well, I didn't even write the whole equation. But we know that it's going to end up, well, it's going to end up going positive at the end. So what we can say here is that as x goes to positive infinity, this way would be going to positive infinity, y is also going to positive infinity. And the odd degree, and in the odd degree, it looks kind of like this disco guy, right? So on one side it's going to positive infinity, on the other side it goes to negative infinity, so it's going to come down this way, and then we would say, okay, well, as x goes to negative infinity, y is going also to negative infinity. I can change that if I made this, here let me use a different color. If I change this and make this a negative out here, that's going to reflect it. And so now it's going to be going this way at the end and that way at that end. And so then this would change as x goes to positive infinity, y goes to negative. As x goes to negative infinity this way, y is going to positive infinity. Okay, so that was an odd degree leading coefficient. We can also, oh, that's hard to see through, but there we go. We can also talk about an even degree. And so if I have y is equal to, I don't even really care. If I have that and that's the largest degree, then what we know is that it's either going to, it's going to do the same thing on both sides. So it could do all kinds of crazy things in the middle, but what happens is it's going to go to positive infinity and positive infinity. Oh, I lied. That's positive infinity. My bad. Okay, so it's going to go, or I can reflect it by making this leading coefficient negative. If I have something a negative and this is still even and everything is getting smaller, then what we know is we'll say that as x goes to positive infinity, y goes to negative. As x goes to negative infinity, y also goes to negative infinity. And this is the notation that we use anytime we ask about end behavior. What does it do towards the end of the function? Okay, let me go ahead and set this. Leading, okay, so on this one, it's got this value right here. That 0 has a multiplicity of 2. That one would have a multiplicity of 1. And its leading coefficient would be positive since it's going off to positive infinity. Yeah, okay, let's see. Write the equation in factored form. All right. I'm not going to do the others. I'll let you practice that. This looks to me like negative 2, so it's x minus a negative 2 becomes plus negative 2, and it's squared. It could be to the 4th or the 6th or the 8th power, but let's, if I want you to think it's a bigger even power, I will tell you explicitly. So let's just do the smallest that we need, and then we're going to multiply this. Looks like 1, 2, 3. Okay, and then write the equation in standard form. We'd need to FOIL this out. So I would say this is x minus 3 times. I'm really good at FOILing this. Remember, that was what I suggested you write on your bathroom mirror so that you really get it in your head. And then I'm going to multiply the x through. And then I'm going to multiply the negative 3 through, and I'm going to line it up so that my like terms are on top of each other. And then I end up in standard form. X cubed, this would be a plus x squared. That becomes minus 8x and minus 12. And so there's the equation. It's not an equation until it has an equal sign, and there we go. I'll let you practice the rest of this. One thing that we might need to do, this one right here does have a y-intercept of negative 12, and this has a y-intercept of negative 12, so we're good. Now what we might need to do, say this had been, say instead this right here was actually negative 24. Then what I would do once I come up with this equation is I would, or I could do it here, I could put an a out in front of all of this. And then when I plug in 0, I can plug in 0 here, I can plug in 0 here. I need to get a y value of, in this case now, 24. Okay, so then I could say, well, this one's a lot easier, 0, 0, 0. Then this becomes, sorry, I should have gotten more paper. Negative 24 is equal to a times negative 12, therefore giving us a is equal to 2. So it could be, you might need to look at these y-intercepts to see, is there a constant that multiplies through the whole thing?